This conference will now be recorded.
Clear. Then more confidently that one can administer the injection to the patient, and those are administering the injection. They were having the hand stability. It is again, this procedure is made very easy with this injection device, and very accurately this is administered in the particular layer of the skin. So we have seen already this, there are different these layers, and upper layer, middle, and intramuscular layer. And according to the type of the injection and intention, we want to give the injection for particular disease condition. So this accuracy is we can get by this injection device. Then novelty, all type of the injections, intradermal, subcutaneous, intramuscular, intravenous, we can give with this device. It is easy for healthcare workers to give the injection. Then self administration of the insulin, that is again possible to the patient. I observed the problem in the rural area, that diabetic patients, so they are getting too much problem, that unavailability of the doctor or nobody in the home to give the injection, and due to that patient came in the hospital with the high grade of the this sugar level, and in the critical condition. So if patient can able to take self, then this problem is minimized. Then it is a cost effective for the Indian scenario. Many devices I have reviewed while doing this patent. Then it is some devices require the electrical support, and cost of the devices are very high. And this device is very simple and easy way, and very with very low cost we made available for the diabetic patient. So you can observe this device, prototype of this device. So there is a, in figure you can observe that there is a various types of the injections. This intramuscular injection, it requires a 90-degree angle. Again, subcutaneous injection requires the 45-degree angle. Intravenous injection, again it will be required the 25-degree angle. And intradermal, for intradermal injection, 10 to 15-degree angle is required. So these are the parts of the device. This syringe holder with two extra appliances: primary angle chart, primary pointer, secondary angle chart, secondary pointer, base, central seat, screw, nut, and stopper. So these are the various parts of this device. This one is a base, and there is a left side, there is again primary angle chart, and right side there is again secondary angle chart. You can see the angle, use this angle while administering the injection to the patient. And again there is a syringe holder is there. This is a syringe holder, and it is made for the 10 cc syringe. And two appliances are there. We can use according to the injection. So with we can give the all types of the injections. So here there is again calibration is a 10, 20, 30, 40 up to 90 degree. And here again in the left side there is again this 15 degree, 45 degree, and 90 degree calibration is there. So those we require that according to that we can use the either side of the this angle chart. Then this device is an insulin device. So this device one can use, that patient can use for the self-administration, and this healthcare personnel they can use for giving the insulin injection to the patient. So this device again there is a base hole shaped slit is there, and there is again holder is there. So this angle 45-degree angle is a fix for the insulin syringe guide. So this is again prototype structure. There is a syringe holder for the 10 cc. So that is again fixed for the this device. So the syringe holder having the cylindrical shape, and which there is a provision of insertion of the 10 cc syringe. So length again 46.96 millimeter, extended diameter 21.5 millimeter, internal diameter 17. Syringe holder guide is again mounts on the base, syringe angle moves in various angle up to 90 degree. So at 90 degree, it is again make lock. Then another this syringe holder for the 5cc. This is an extra appliances. So you can see in the figure, these are the extra appliances. We can use if there is a 5cc syringe, we can use the 5cc these extra appliances. If 2cc, we want to give this less quantity of the this injection to the patient, then we can use the 2cc. So this syringe holder for the 2cc, this is the extra appliances we can use, and we can give the small quantity of the injection to the patient. So these are the again these angle charts on the base left side that 15 degree, 45 degree, 90 degree angles they have shown, and there is a primary pointer which angle we select. This pointer shows that we have selected the 15 degree, 45 degree, 90 degree. So it is easy for the administrator. Then secondary angle chart, if other than these 15, 45, 90 we want, then there is again 10, 10 degree calibration is there up to 90 degree. So either side we can use these also for the administration of the injection. Then again there is a secondary pointer. The secondary pointer is on this secondary angle chart, shows the degree on chart. So length of the base is 54.5 millimeter and width is 28.8 millimeter. There is a central slit on the base to administer the injection. So there is a central slit is there, and we can keep this device on the patient's skin where we want to give the injection, and we have to make the clean skin with the alcohol, and then we can place the device on the this patient's skin, and we can administer the injection by choosing the appropriate angle. So by placing base of the device on injection site, we can administer the injection. So base provides firmness for the injection holder. It gives stability while administration of the injection. Central slit, it is a longitudinal slit 5 millimeter width and 16 millimeter length. It is useful for the administration of the injection into the skin layer. Other these parts are the screw, nut. The screw helps attach syringe holder to the secondary angle chart, and nut helps to the attach syringe holder to the secondary angle chart. So this another device that this one is a this insulin syringe guider, and it is a separate device, and one can use for the administration of the insulin injection. So patient can take self, or these family members, they can administer injection insulin safely to the patient in the home without fear. So this insulin injection is given into the subcutaneous layer. So it is again layer, superficial layer of the skin, this epidermis, dermis, and then there is a subcutaneous layer. So 45 degree angle is used for the giving the injection insulin. So we'll see the prototype. There is a 3 parts: insulin syringe holder. Insulin syringe holder having the cylindrical shape in which there is a provision of insertion of the syringe. Length of the syringe holder is a 27.51 millimeter, and external diameter is 10 millimeter, and internal diameter is 7 millimeter. Insulin syringe holder is mounted on the base. Syringe angle is fixed at 45 degree angle, so it helps to administer subcutaneous injection safely. Base length of the base is a 26.83 millimeter, and width is a 16 millimeter. There is a round slit at anterior side of the base to administer the injection. By placing base of device on injection site, it is easy to administer insulin injection subcutaneously at 45 degree angle. Base provides firmness for the syringe holder. It gives stability while administration of the injection. Again, there is a oval-shaped slit. It is a small oval-shaped slit. It is used to insert needle into the skin layer. The total height of the insulin syringe guider is a 20.09 millimeter. So in the figure, you can observe that there is a various sites are shown to administer injection insulin. So if patient administer injection self, so they can use this abdomen side, they can use the lateral aspect thigh. So that is easy for the patient if they are administering the self-administration. If anybody other members want to give injection to the patient, they can use the other sites also. So they can use these arms, they can use abdomen, lateral aspect of the thigh. Again, this buttocks region, they can use for the giving the injection to the patient. So there is again this very small device is we can very safely we can administer injection insulin to the patient. So I got the patent for this device. So in the month of the June 19, and this patent also published in the international journal also. So this device approved by the medical administrator, management, our management, and Krishna Institute of Medical Sciences deemed to be university, and medicine doctors of the Krishna Hospital Medical Research Center, Karat. We have taken the clinical trial on the 50 patients. Again, we have taken trials on the staff also, how they feel, how whether they are easily administered to the patient or not. So result we got that there is a very good hand stability and good they give this reply that there is a stability and confidently they can able to give the injection to the patient, and complications were nil, and without fear, there is no fear while giving the injection to the patient. And we have seen on the face of the patient taken the facial feelings also that we observed that there was no fear on the face of the patient. They easily they have taken the injection insulin. So these from these two devices, one device that now we have taken this product into the final stage, and for the pilot study 1000 or for the 1000 patients, we have made this. This one is a user guide, and by this insulin guide, that way insulin syringe we can uh, uh, like this we can administer to the patient, and uh, like this we have made, and we brought this product into the market. So this for this device, I get the patent on 21/6/19, and international publication also done by the patent office, and I get the felicitation by from the our university, and this insulin device is under the pilot project. So these many times these errors were noted by an unexperienced staff nurses, professionals, and patients suffer with the complications. So during when I worked in the clinical area, 14 years I worked in the clinical area, and that time I observed these little bit errors that can be happened by the nurses, new nurses, student nurses, and some healthcare professionals also. And with that, patient suffers a lot of that problem I observed, and this idea is generated in my mind, and my son is helped for developing this device. He's a mechanical engineer, and doing these 3D printers prototype he's doing, and he helped me for development of this device. So this device again helps accuracy for the injection in cost-effective manner. So there was no intention of this again profit, but solving the problem of the community. That is the intention of our university, and they have helped me for the all support required. They have given to me for developing this device, and without this support, it was not possible to develop this device. So I will show these uh, videos uh, that we have used for the patient.
मैडम आप वीडियो दिखा रहे क्या अभी?
हाँ सर।
हाँ तो लगाओ ना, जल्दी लगाओ ना, लोग छोड़ेंगे नहीं तो उसको।
एक बार देखती हूँ सर। ओपन नहीं हो रहा है।
छोड़ दो उसको, उनको बोल दो हमारी वेबसाइट पे है।
हाँ
हेलो,
these videos are,
मेंशन करो
हाँ सर,
वेबसाइट पे।
हाँ these videos are available on our website KMSDU
इनोवेशन गैलरी।
in the innovation gallery. So I am very thankful to the Tulas Institute, Dehradun, Uttarakhand, for giving me opportunity to present my this device in this training program. Also, I am very thankful to the our university, Krishna Institute of Medical Sciences, seem to be University Karad, and thankful to the Rio 3D printers, Malkapur Karad, for the helping me developing this patent, and all participants. I am very thankful. Also, I am thankful to our management, our Chancellor Sir, Dr. Suresh Bhosle, Pro Chancellor Sir, Dr. Praveen Shingare Sir, Vice Chancellor, Dr. Neelam Mishra Madam, Registrar Sir, Dr. Khurpade Sir, Research Director, Dr. Risput Sir, Dr. D.K. Agrawal Sir, Dr. Patil Sir, our Principal, Dr. Vaishali Moisi. So without their support, it was not possible to develop the device. So thanking you very much for giving me this opportunity. Thank you, sir.
Thank you, ma'am. Can you hear me?
Sir. Hi, madam. Yes, ma'am.
Okay, ma'am. Thank you so much, ma'am, for your presentation and your views. This will definitely beneficial for the society.
Thank you, madam.
Good afternoon. I am Renu Thapliyal. Yes, ma'am. Good afternoon. I am Renu Thapliyal from Tech Counselor. Welcomes to all audience and participants to this international training and internship program, an opportunity for R&D and tech-driven startups. We have started this 1 month internship program on 20th June, and now we are about to end the program by tomorrow. This program is organized by Tech Counselor and Tulas Institute in collaboration with Krishna Institute of Medical Science, deemed to be University, Maharashtra. We are thankful to our sponsors, Uttarakhand Technical University and TQ. Also thankful to our knowledge partners, Yuvayana Tech and Craft, Boudik Venture, Ramanujan Academy, Swachh Neer, and to our CSR partner, Kaviraj Foundation, Trides and Seva. We are organizing this program under a virtual network of Indians, AVNI, an initiative of Tech Counselor. Thank you all for making it.
Renu madam, can I interrupt?
Kindly, yes.
Just for a minute. I am Dr. D.K.
Yes.
Agrawal from Krishna Institute of Medical Sciences, Karad.
Oh.
I'm looking for.
Okay, welcome, sir.
I'm looking for all these IPR activities actually in this institution. Right now, Dr. Rajshree Karade has shown you the prototype and presentation on the injection guide. And likewise, in the same manner, this is a patented product. And we have 15 patented products in our institution. So I would like to share some. I want to connect with some startup. If you could help us in connecting with some of the startup in the medical device, then I want to connect with some of the startup. Those are involved in the medical healthcare devices. So that will be our second agenda. Why we have been connected with you and co-sponsored with you for this training program. So later on, at any
Yes,
other point of time, later on at any other, good afternoon. I am from Krishna Institute, Dr. D.K. Agrawal. We have about 15 patented products.
Yes, sir. I have heard you.
Yeah, 15 patented products, and I want to connect with some.
Yes, sir.
I want to connect with some of the startup. If you can help us to sign some MOU with the startup, as you are working on the same line, so it will be a great help for our institution.
Yes, sir. Yes, sir. I had word with Dr. Jain Pawar also into this regard.
Okay.
and
Yeah.
I'm very much excited, and I was very much happy about hearing this information from the management and from the institute. Like, you guys are having these many patents and have been working on technological innovation for the past, I think.
Yes.
So
Yes.
we
Yes.
will definitely be connecting with Krishna Institute regarding that part also, and we'll try our best to connect
Yeah.
you with the startups as well as with those kind of funding agencies which are most interested toward these healthcare innovations. So
Yes.
Pawar sir and I was having detailed discussion regarding this, and I also got to know that you guys are into some gallery kind of thing for the innovation gallery.
Yeah. Innovation gallery. Yeah. Yeah.
Yeah.
So, sir,
So we will be
even
having, yes, sir.
yes, yes, please, please.
Yes, sir. So we definitely will be helping out Krishna Institute in that part, and we also want to have that kind of collaborations. And we hope that, because this program was basically for that part only, we wanted to have a startup ecosystem to be on the front line, and more
Right.
toward like this R&D and tech-driven kind of thing.
Okay. So once you finish this training program tomorrow, so later that part at one point of time we can have sharing on the virtual platform at individual level, and we can show our other products also, and then we
Yeah,
can join some of the startup through you
definitely,
by
sir.
signing some MOU and agreement and all that. Okay. May I know your
Definitely,
good
sir.
name, please?
Definitely, sir.
May I know
Sir,
your good name, please?
This is Mukesh. Sir,
Uh,
this is Mukesh from
okay.
Tech Counselor team. Yes,
Okay,
sir.
okay, Mukesh. We will be in touch. Jayan Pawar will be in
Sure,
touch
sir.
with you.
Sure, sir. Sure, sir.
Okay.
Thank you so much, sir, for
Chalo.
connecting. It's really
Thank
great
you.
place for us also that you are over here.
Right. It's my pleasure. Thank you. Thank you. Bye bye and good
Thank you,
luck.
sir. Okay, sir. Thank you so much. Handing over to Renu again.
Thank you so much, sir. And thank you all for making this session a wonderful and successful event. We had received around 1200 plus queries for the registration to this program, out of which 187 were registered. So far, we have 10,000 plus views on Facebook and 2,500 views on YouTube to the session, which were taken by the 15 plus experts from the various domains. Today, we will having our 20th module in this series by Mr. Udayveer Mittal from Tech Counselor team. And additionally, we have received 7 presentations from participants who were interested in sharing their ideas and views, out of which 2 experts were selected. Yesterday, Mohan sir briefly explained on IEEE, and today we had Mrs. Rajshree, Associate Professor at Krishna Institute of Medical Science, deemed to be University Maharashtra. She already had shared a brief presentation on her patented technology, which will surely beneficial for for all. Now handing over to Mukesh for the short brief intro of Udayveer Mittal.
Yeah, thank you, Renu. Firstly, I'll thanks to Dr. D.K. Agrawal sir for being with us for the whole event, and we are very much thankful to the whole team of Krishna Institute Medical Science Team to University for supporting us with the event. I'm also very much thankful to my all sponsors and organizers for supporting the program. Today we have Uday with us, one of the youngest member of our team. Today we have Uday with us, one of the youngest member of our team, who is having core expertise on embedded, on R&D, and on the IoT front. He have been working on these technologies with us for the last 2-3 years, and have worked on various R&D projects. Also have 2 patents to his credit from the Tech Counselor. Additionally, he is also part of 3 R&D projects, which are funded by the state government, and which include like rain attenuation project, one of our like very mega project. And then he's also working on solar tree and on the drone tech project. So I welcome him, and I'm very much hopeful that his work and his expertise on this tech-enabled domain will be helpful to all the audience. So requesting Monica to make him presenter, and Uday, very best of luck, and I hope that you will be having a wonderful session with the audience.
Thank you so much, sir. Thank you so much, sir. Am I audible?
Yes, 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 you're audible.
Yeah. So, thank you so much, sir. Now I would like to start. So, I'll share my screen. If you could just make me the presenter.
Yeah, Monica, Udayveer is having the presenter access. Uday, you have got the access?
No, sir, not yet.
I'll just check with Monica.
So I hope my screen is visible to all. Is the PPT visible? Someone could just confirm it in the comment box and I will proceed. Okay, thank you. Yeah. So,
Uday, you have got the access?
yes, sir. Is my PPT visible,
Oh,
sir?
yes,
On the
visible. You can put the slideshow mode on.
okay, sir. Right, sir. Okay, so
Okay, good to
first of
go.
all, I'd like to right, sir. Right. First of all, I'd like to thank tech counselors and Tulas Dehradun, Krishna Institute of Medical Sciences, and TEQIP for giving me this opportunity. So, in this lecture, I will be talking about the hardware implementation for R&D. First, I'll give you a briefing that what exactly R&D is about, what all it entails, and then we look at some microcontrollers, the ones that we generally use for rapid prototyping. And then we'll dive into the coding part and I'll show you all the softwares that are required and everything and how to go about it. So first of all, for the question is what exactly is R&D? So R&D, as we all know, stands for research and development. It is the process by which a company works to obtain new knowledge that it might use to create new technology, products, services, and it is it is a collection of activities that a company undertakes to innovate and introduce new products and services to improve their existing offerings. So R&D, why is it necessary? Because it allows a company to stay ahead of its competition. We are constantly evolving. We constantly need new products, new services, easier way of doing the same thing, simpler ways, and most importantly, cheaper way of doing the same thing. So there are two types of research that are there. One is basic, second is applied. In this lecture, we will be talking about applied research. What is basic research? Basic research helps the company acquire new knowledge, but it is not having any specific application or use in mind. Whereas applied research is done to acquire knowledge with a specific goal in mind or a product in mind. So whenever we are working in some company, we always do applied research in order to make a new product which the company shall be able to launch sooner or later. Another important aspect of R&D is that there is no guarantee of success. So you should always go into R&D with an open mind that even though you are spending a lot of time trying to develop a new technology, the company will invest a large amount of money in search for a faster or better way of doing something. There is no guarantee that you will find that. It might be that it is a total loss or a partial success. R&D is not an asset, it's an expense. And for that reason, general accounting standards and practices dictate that most costs associated with R&D shall be charged to expense as incurred. So why am I telling you all this? Well, this is because of all these things, there are certain constraints that we have to keep in mind, such as it should be of minimal expense. So the constraints for building a prototype are that the prototype should be easily, it should accept changes. The prototype should be made in a modular manner so that you can keep changing it very fast. Why so? I'll share a personal experience. What happens is that when you build a prototype, for you it's easy the best. But when you take it to your senior, or maybe the owner of the company or your technical head, he will point out so many problems with it that he wants it in some other way. So if your prototype cannot accept changes easily, then you'll have to start over from scratch. So first thing we need to keep in mind is that it should easily be able to accept changes. Second, we don't need very high quality parts when building a prototype. Remember, it's a prototype, it's not a product. When you build a product, you have to keep a lot of things in mind, that what will be the life of the product, that it should work for, let's say, 5 years, 10 years, whatever your aim is, 15 years maybe, if you're talking about an automobile or things like that. But when you are building a prototype, right now the company is not earning anything from that. It's just an expense. So you need to keep the cost to a minimum. And third thing is, you have to be fast with it. So if suppose you have two options and one is faster, you always go with the faster option, because basically if we just talk about that particular project, then it's running in a loss because company is not earning anything over it. So prototype should be able to accept changes easily, and cheap parts, not very expensive hardware, and third is fast, because all we need to do with a prototype is to prove a concept that yes, it is possible. Then coming to embedded systems, I hope you all know what a computer is. So in a general computer that we all use, we have a CPU, or in laptops we have everything under the screen. So a CPU consists of a processor. Suppose you have Intel i3, i5, i9, or whatever. Then there is some memory, your hard drive or your solid state drive. Then there is a RAM that you have. Then there are certain USB ports on a computer. But when you combine all this into a single unit, that unit is called a microcontroller. And when that is designed to do a dedicated function, then that system is known as an embedded system. For example, if you talk about the washing machines that we have, they're all microcontroller based, but they're dedicated to that task. The microcontroller has to take inputs from the user, that okay, what type of cycle you want, 30 minutes, half an hour, soft cycle, hard cycle, and things like that, and then it will implement that. That's it. So it is a dedicated mini computer for performing that task. So when you have a dedicated controller or computer doing that, it is known as an embedded system. So other examples can be ATMs, elevators, escalators, modern water heaters, air conditioners, inverters, all are microcontroller based now, and they are known as embedded systems. PC is not an embedded system. Why? Because it is a general purpose thing. You can do a lot of things on it. It's not dedicated to a particular use. Whenever we go into dedicated stuff, it is embedded systems. The electronic control unit on your car, it is an embedded system. Okay. So next question is how to select a microcontroller. There are so many microcontrollers available in the market, but how do I know which microcontroller I'm supposed to use for my prototype? So generally there are two criteria for deciding. First is how many pins do I require. Pins are basically inputs and outputs. How many inputs and outputs I require, and how many of them need to be analog and digital. I'll talk about analog and digital later in the lecture. And second criteria is what should be the processing speed. Like like I hope you know, like when you buy a new cell phone, so when you look into the specifications, it tells that the processor is of 2 gigahertz, 2.5 gigahertz. So that is the processing speed of that processor, the maximum processing speed. Similarly, when we talk about microcontrollers, we have a maximum processing speed, which are not in gigahertz, they are in megahertz. So for example, if you go with the basic Atmel 322 chip, then it will have a processing speed of 16 megahertz. That is the basic standard that is there. If you go for higher variants of microcontrollers, it can go up to 120 and at times even 180 megahertz. But that is the sort of the range for microcontrollers. So how fast do we need a system to respond to external stimulus? For example, in a washing machine, you don't need a very fast microcontroller. 16 megahertz, that is 16 into 10 to the power 6 times in a second. It is checking for inputs. That is fast enough. So that's fine. For a washing machine, you don't need that. But maybe for something like a detection device, or maybe something where you need to do a lot of processing, you need high processing speed. For example, if you want to implement PID loops or make self-balancing robots, make drones, quadcopters, then the processing speed needs to be really, really high so that the device is able to balance itself. So it depends on what you're trying to make, where you are trying to implement it. So let's have a look at the general microcontrollers that people generally use. Just a second. Yeah, sorry. Yeah. So the general microcontrollers that people use. My bad. Yeah. So first of all, the very basic thing is the Arduino microcontrollers that are generally used. Uh, Let me tell you something first. In an Arduino board, the microcontroller is the chip on it, and everything around the chip is the Arduino hardware that they've made it so that people like you and me who are not into AVR programming can also use the chip. Otherwise, had Arduino not made it so simple, then the rapid prototyping would not have been there. So they revolutionized it. They made it very fast with the softwares and the circuit around the chip so that rapid prototyping is possible and everyone can learn it very easily. So there are a lot of models in Arduino microcontrollers, the Uno, Nano, Pro Mini, Mega, then there is Dew, which is even higher end. Then we have TNC microcontrollers. These are a bit expensive when compared to Arduino, but their quality is really good. So if you are just a beginner, I would suggest you stick with the Arduino Uno or Nano, and then as you get some experience, you can go on using TNC microcontrollers or Node MCU series. Now, Node MCU series has a specialty that it has inbuilt Wi-Fi, which is not there in Arduino or TNC microcontroller. So if you want to do something related to IoT, then Node MCU is going to be your first choice. So that's how you select a microcontroller. How many pins do I require? Then what is the processing speed? And in special cases, do I need Wi-Fi or Bluetooth? So if you need that, then you can just go use the Node MCU series like the ESP8266. It has a Wi-Fi, inbuilt Wi-Fi, so very easy to use. Or you can also go to WROM32 module, which has inbuilt Wi-Fi plus Bluetooth if you want to control something using your smartphone or something like that. Okay, so moving on. Yes, another important aspect is control system and control loops. So what is a control loop? I won't go into the details. I'll just give a briefing about it because this is a topic on its own. A control loop is the fundamental building block of an industrial control system. It consists of all physical components and functions necessary to automatically adjust the value of a measured process variable to equal the value of a desired set point. Now to explain it, I use this diagram. So this is the schematic of a typical control loop, a very simple one. I hope you all can see that there is an input. So let's take an example of an air conditioner. Suppose you give the air conditioner an input that I want the temperature of the room to be 25 degrees Celsius. So your input is 25. Your input, it is 25. Now do you see this feedback element? This feedback element is the actual sensor which is measuring what the real temperature of the room is. Let's assume it is 32 degrees Celsius. It's hot outside, it's 32 degrees Celsius. So this feedback element is a temperature sensor which will tell that you want the input is 25, this is what we want, and the feedback element is telling us but that it's not 25, it's 32 degrees Celsius. So you see this crossover here where input is plus and error and feedback signal is minus. What will happen is that this is known as a summing junction, which is also known as an error detector. What happens is you subtract 32 from 25, you get minus 7. Your desired error, this is known as error. Input minus feedback is error. So you wanted 25, you are getting 32. So that means you're not where you are supposed to be. So what happens is 25 minus 32 minus 7. Our error is minus 7. This will be that will chip, something like that. And then controller will analyze it. That error should have been 0. That's what we want. We want the temperature to be 25. So in an ideal case, it should have been input is 25, feedback is also telling 25, error is 0. But the controller senses that error is not 0, it's minus 7. So then what it will do, it will send a signal to the plant being the compressor of the air conditioner. the fan is, let's say, always running, so it will send a signal to the compressor that you need to switch on, man, because the temperature, it's hot and the desired temperature is lower. So that is the actuating signal. It will make the compressor turn on, and then the compressor will start cooling after, let's say, 15 minutes, 20 minutes. Let's say the temperature of air is 26. Then again it will go to the summing junction, 25 minus 26, still not there, almost there, but still not there. Again to the controller. The moment it's 25, the controller will shut off the plant that, okay, we are where we were supposed to be, and it's fine. All good to go. That's what the user wanted. So that's how this cycle uh, keeps going, and that's what happens when we write a code. It keeps looping. Looping is a term when something is going on from head to toe, and then again you are again and again analyzing it. So we keep looping the code just like this cycle. It keeps going on and on and on and on until a desired condition is met. And even when the desired condition is met, even after that, the processor keeps analyzing that it should stay in the desired condition. Okay, so moving on, this is the Arduino Uno board that we'll be talking about in this lecture. This is a schematic of that. So as you can see, this is the DC power jack from where you where you will supply power to the controller. This is the USB port. This port is used to connect your Arduino to your computer so that you can upload the code onto it. Then there is also a reset button. There are a lot of pins. There is a left side and the right side. So let's talk about the left side first. At the bottom, you will see it says analog input right here. Analog input from A0 to A5. These are 6 pins. First of all, always remember that when we are doing coding, whenever we talk about computer science, numbering starts from 0 and not 1. So the first pin is always 0, and the 10th pin will have a number 9 to it, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 will actually represent the 10th pin. That's how it works in computer. So coming back to analog inputs. So these 6 pins are reserved for analog inputs. This is analog pin 1, analog pin 2, 3, 4, 5, and their name is A0 to A5. Also, if you notice, it's written I2C oblique SDA, I2C oblique SCL. This is, once we know the basics of a microcontroller, we talk about advanced stuff. So these are all communication protocols which we will not discuss in this lecture. Then there is this bank of pins which says power. So first is VIN pin, voltage input. VIN stands for voltage input. It can accept a voltage from 7 to 12 volts. Our Arduino will work at 5 volts, but it can accept any voltage to 12 volts. Then the next 2 pins that we have are ground. Next is 5 volt. You can also supply 5 volts from this pin, but then you should be careful that if you supply even 5.1 volts by mistake, then with this chip over here, the real microcontroller, it will fry. Then there is 3.3 volts, because there are some sensors which work on 3.3 volt level logic, so that has also been provided. Reset pin, if you want to digitally reset the Arduino instead of using this button. 5 this is IOREF. This is no connection, so this is a blank. Coming on the right hand side, there are digital pins numbered from 0 to 13. We'll talk about what digital and analog is right in the next slide, but just have a look that there are 14 pins, out of which you should never use 0 and 1, because they are reserved for serial port transmission and receiving signals from a computer. You can use them, but then you won't be able to dump a new code on the microcontroller until and unless you disconnect these pins. So generally we don't use it. We start using from 2 to 13. So 2 to 13 is a lot of pins. 11 14 actually, 12 pins you got, so good enough. Then there is ground. Then there is AREF, analog reference voltage. Again, I2C, SDA, SCL, same pins data over here. Alright, so this is the general architecture of this microcontroller. So this chip is by Atmel. They've been making it since quite some time now, and everything around this chip is what Arduino has done. So the Arduino company, they made all this hardware so that even people who don't have in-depth knowledge of electronics are able to use their microcontrollers and are able to do rapid prototyping. And yeah, so that's that. Now moving on, what are digital signals? First of all, digital as well as analog both are direct current. So don't never ever of this graph of analog that we are talking about AC electricity. No, we are not. We're talking about direct current. In direct current, there are two types of signals. There is a digital signal, there is an analog signal. So what is a digital signal? Digital signals are signals which give us only binary information, such as yes or no, true or false, 1 or 0, on or off. As you can see in the graph, it's high or low. There is no in between. At a time, it is either 5 volts or it is 0 volts, 5 volts, 0 volts, 5 volts, 0 volts. There is no other possibility. It will either be 5 or 0 in case of the Arduino Uno, or maybe if you use some other microcontroller which works on 3.3 volt logic, then it will be 3.3 or 0. But there are only two voltage levels possible. That is, there are only two possible states of signal. It will either be high in case of Arduino Uno or low. No other value is possible. That is a digital signal. It only tells us if something is present or absent. Whereas when we talk about analog signals, well, an analog signal on the other hand gives us a lot more information. Other than on or off, they tell us what the magnitude is. For an Arduino, an analog input can be any value between 0 volts and 5 volts. So although in this the graph is going below the line, but nowhere is it mentioned that this line is 0 volts. So basically this point is 0. Okay, sorry. Uh, this point over here, this is 0 volts, this is 5 volts, and all the values between 0 and 5 is possible. And it is not that it will work in the sinusoidal manner. I can say 3 volts, 3.1 volts, 3.12 volts, 3.14 volts. It depends on me how I want the signal and how the receiver will interpret the signal. So that's how it is. There are two types of signals, as I told you, digital and analog. Are 6 input pins for analog signals, and there are two, like 14 if we include everything, 14 pins for digital input and output. So the same pin, let's say pin number 10, can be used to give an output and it can be used to take an input from the outside world. Both are possible. As far as the analog pins are there, analog pins can be used to take an analog input. They can also be used to give a digital output. And yes, there are some pins which mention PWM, 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 fifth, sixth PWM, third PWM, 9, 10, 11 PWM. So we'll talk about that later in the lecture if we get time. But basically right now all you have to remember is that there are two types of pin, analog and digital. Digital, high or low, yes or no, true or false, 1 or 0, on or off. Magnitude is also associated. It's 0 to 5 and any value between them. Sensors and output devices. First sensor or output device on the screen is a buzzer. So that's an output device. It can't sense anything. It will take an input from the microcontroller. Microcontroller will give it an output. It will produce a sound to tell the user that to indicate something, whatever we have programmed it for. So it is a digital it is a digital output device. You just give it 5 volts, it will make a sound. That's it. Done. Give it 0 volts, nothing will happen. IR sensor, this is a proximity sensor. Whenever there is something present in front of it, it will send a signal to the microcontroller, in our case the Arduino Uno, that yes, there is something present in front of me. It can't tell you how far that is, 5 centimeters away or 1 centimeter away. It only tells you yes, there is something present in front of me. That is why it is a digital sensor. It only tells you yes, 5 volts, no, 0 volts, finished. Next we have a relay. So just like the buzzer, if you want to control something, let's say a light bulb or something, you can't interface it directly with the Arduino because an Arduino works on 5 volt logic. A relay and a light bulb, let's say, works at 220 volts. So now Arduino can't drive that light bulb, so it needs an interfacing medium. So this relay is an interfacing medium. A relay, I hope you all know what a relay is. A relay is an electromechanical switch. So what happens is that when you give it power from the microcontroller, there is an electromagnetic coil which gets actuated. It magnetizes, it pulls a switch towards itself, and a connection is made because of that. And that completes a connection in another circuit, which is of the light bulb, and the light bulb turns on, or a fan, or anything that you wish to, any motor, pump. It's limitless. Possibilities are limitless. Then this is a switch. It is a digital sensor. As we say, it will, whenever you press it, it will pass the 5 volts to your microcontroller, and the microcontroller will know, yeah, yes, I have received an input from the user. So again, it is just on or off. Another variation of the same switch is this keypad over here, which has got so many buttons, 4 by 4, 16 buttons on it. So all of these are digital. Although we don't need 16 wires, we use another protocol to interface this. It is known as DTMF, dual tone multi-frequency, but then again it's another topic. So these are some digital sensors and output devices. And there are some analog sensors as well, analog sensors and output devices. So if you remember in the previous slide, yeah, this one, we talked about a proximity sensor, which tells you if there is someone in the proximity, like the sensor you have on your cell phone. When you keep it next to your ear, it switches off the screen so that by mistake you don't actuate anything on the touch screen. It doesn't tell you how far the ear is, it only tells that yes, something is there. But we also have infrared proximity sensors which can tell us how far something is. So this one is an analog sensor. So this particular sensor has a range of 0 to 100 centimeters. So it can detect anything up to a distance of 1 meter, and it can also tell you how far that object is. How does it do that? Well, what is done is, instead of it returning just a digital output of 5 volts, it gives you a value between 0 and 5. So if there is no one there, it will give you 0. If there is someone at 90 centimeters, maybe it will give you a value around 0.5 volts. If there is someone at a distance of, hello, yeah. If there is someone at a distance of, let's say, 2 centimeters, it will give you 5 volts. So like that, in that way, we have to interpret the voltage coming from our proximity sensor, that how much voltage is it returning. The more the voltage, the lesser is the distance, like that. So that's how it works. So for that, I'll show you all the codes and how to go about it. Next, we have a very common thing that we use with electronics, that is a motor driver. This is a L29 3D motor driver. It has got a lot of connection. As you can see, 3 blue terminals there, 2 over there, 2 over here. So this is where the motors are connected and all. But the important aspect are these pins over here. What we do is we give it an analog voltage again to control the speed of the motor. There are two ways to control a motor. Suppose you want a motor to just switch on and switch off, that's one thing. Like in the case of your pump, the pump that you have at home to supply water to the tank at the top of your house. So that's either on or off. But what if I want to control the speed, control the rate at which the motor which is driving the pump is working? Suppose I have a DC motor and I have a DC setup. So what I'll do is I'll hook this up, this particular module, the red one, and what will happen is I will give it a PWM signal, which is again a type of analog signal. And what happens is that when I give it 5 volts, the motor runs at full speed. I give it 0 volts, the motor does not run at all. I give it 3 volts, or let's say 2.5, the motor will run at half the speed. So it's like that. It's like a linear interpolation kind of thing. That 5 volt represents the full value, 0 represents nothing, and all the values in between represent whatever the ratio comes up. Similarly, we have the sensor. This is a current sensor. So suppose you want to find out how much current is actually flowing in an electrical circuit. So you just hook this up in the circuit from this side, and these 3 pins go to the microcontroller, that is to the Arduino Uno in our case, and it will give you a voltage. So this current sensor will come with a rating that it can measure 25 amperes. So what does that mean? That means that when 25 amperes will flow through these two terminals, this sensor will return a value of 5 volts. And if no current will flow, it will return a value of 0 volts. So if 12.5 volt flows, 12.5 ampere flow through this sensor, then it will return a value of 2.5 volts, and like that. Okay, and suppose 2.5 volts flow through it, 5 volts flow through it, it will return 1 volt. So that's how our controller will know how much current is flowing through a certain circuit, and maybe if it needs to limit that current or not, depends on the application again. Then we have this sensor over here, this is the LDR. This is a very common thing that you will find on electronic circuits. So what is the LDR? LDR is a light dependent resistor. As you can see, there is a small coil over it made of copper. So what happens is that when light falls on it, the resistance of this coil, it changes, and we measure the resistance of the coil using our microcontroller. So suppose it's in complete darkness and the resistance will go all the way up to like more than 100,000 ohms, 100 kilo ohms that is. And if there is a lot of light, let's say you put it in direct sunlight, then it will drop to somewhere around, like 3 or 4 ohms. So that's how drastic the change is. So we use that to measure the amount of light, ambient light present in a certain area. And application of this is the automatic brightness sensor that you have on your cell phone. So when you put your cell phone on auto brightness, there is a small light sensor on it which measures how much light is there in the environment. If you are in sunlight, then it automatically brightens the screen. If you are in dark, then it automatically reduces the brightness of the screen. So that's how it works, and that's an application of the LDR used in numerous other places as well. Last but not the least, we've got an LM35 sensor. You see the sensor, this again is an analog device. It is a temperature sensor, it measures the temperature. So this has got three pins or legs as you call it. So out of the three legs, one is 5 volts, that is the power you will supply to it. One is ground. Obviously, we all need 0 volts as a grounding so that the current can flow and a circuit can be completed. And then the third pin is again the output, which will be between 0 and 5. Again, 5 volts will be achieved when the sensor will be maximum temperature, 150 degrees Celsius for this sensor. It will return 0 when it will be at 0 degrees Celsius. So, and so on. So I think that's about it for the analog sensors and digital sensors. Before moving on to the software, I'd like to ask if there is any questions, any doubt that you want me to clarify. Just please comment on it. I am giving you some time to just type the comments, and then I'll reply to you one on one. So any doubt regarding digital, analog, microcontroller pins, anything that you didn't understand or anything that you feel I missed out or any blank spaces that you feel are there, please comment. Nothing. You sure if it's all clear, then you can write a yes or a thumbs up or something like that. Let's make it a bit interactive because once we go into coding, I really need some input from you guys. Okay, thank you, JC. Anyone else? Any doubts, or should I just move on to the software? Okay, I think I'll just move on to the software part. So for using the Arduino controller, you need this software. It is available on the arduino.cc main software. Basically, just go to Google and search Arduino IDE. What is IDE? IDE is Integrated Development Environment. It is something that you need in order to write a program in. So here, the first thing is from arduino.cc. This is the official website. It's a free software. You just open it, and then you can also port online, but I recommend that you just download the ID. It's a very small software, 200 megabytes or 120 megabytes, something like that. So just come here, and here it says download the ID 1.8.13. Then choose your operating system. Generally we all have Windows, so just go for Windows app requires Windows 8.1 or 10. I didn't do that. I went for the normal Windows 7 and up. I don't like the application variant. Just press it and it will take you to another page. Right? It's you can, if you don't wish, don't, and just you can click just download. If you want to contribute, you can write contribute and download. So just press on just download, and the file should start downloading any minute now. And here it's 112 megabytes. I'll cancel it because I already have it. Here you will have this IDE. So this is a previous sketch. Let's see this. Yeah. So this is how a page on the IDE looks. This is your sketch. It will have a default name of sketch July 14A, which means that this is the first sketch of July 14 that we are making. There will be two blocks, setup and loop. That's how every new program is. You open file from here, you do new, and it will open up into a new window, and again it has setup and loop. Alright. So what is setup and what is loop? So, like every coding language that we have, there are certain standard procedures that we need to do. All right, some syntax as you call it. First of all, this is based on C++, but there are some commands that you need to know, particularly for the Arduino IDE. So what is setup? Put your setup code here to run once. All that code which you want to run just once. Suppose you want to initialize some variable, or maybe start something, stop something. You want it only once, not again and again and again. So that is in the setup. And all that, the main code that you want the microcontroller to keep processing repeatedly will come in loop. So these two functions are very important. You can't write an Arduino code without these two. Once you have these two functions, you can obviously create more functions. Create void, sorry, void new. But new is a keyword, so I can't name it that. New. So I can create a new function and always call it from the loop function. But that's something different. We'll focus on that later sometime. First of all, let's say we talk about interfacing a LDR. LDR is what I told you over here. This one. This sensor over here is a LDR, light dependent resistance. Suppose I want to take an input from the LDR. So how should I proceed with it? First thing is I need a schematic. Coding is the last. First thing is a schematic. That is the circuit. How will you connect? First you choose the microcontroller, then you choose the sensors. At times what happens is the sensor is not compatible with the microcontroller. So you first choose the sensor, then choose the microcontroller, and then you make a circuit. So for LDR, this is the circuit. Any one leg of the LDR, doesn't matter which one, both are say equal, same, will be connected to the 5 volts on the Arduino. The other leg will be connected. So first leg will be connected to 5 volts, second leg will be connected to analog pin A0 or A1 or A2 or A3 or A4 or A5, whatever you want. And then the same leg via a 10 kilo ohm resistor will be connected to ground. Why do we do this? I'll show you practically why we do this. But that's how we wire it up. So once we have this circuit ready, then we will go to the Arduino IDE, which is over here, sketch July 14A. All right. So what I'll do is, let's take a few variables. Let's say I have a variable int values. Okay, again it's a reserved word, so I'll go with val. Okay, val is equal to 0. Fine. So this is the value that I have. It is currently 0, and this is the variable in which I want to store the brightness of the light available outside. All right. Now what I'll do is, the main thing is that how will I see where the light is? I mean, if you understand what I'm trying to say, we need an output device as well. All that is happening will stay inside your microcontroller. So we have an inbuilt function which is known as serial monitor. You can note it down because this will come in handy to you. In this ID, there is the search sort of a symbol over here at the top right corner. It says serial monitor. So what happens is if there is any data we want to see, so that data is sent from the Arduino microcontroller to your computer, and you can see it here. When I click see, it says board COM9 is not available. This will open only when there is a board connected to the computer. I'll show you everything. So that's how it happens, but you have to write the statement. So this statement is like an initialization which is required only once the beginning. So that's why we write it only once. We put it in setup. That serial begin 9600. You want 9600 is the baud rate. Not going into the specifics, we'll talk about it later sometime maybe. Serial dot begin. This is a command which you need to memorize. Once you have this, then what happens is you want to take input repeatedly. You don't want to take it only once. That's why you will put it in loop. So the command for taking input, I'll just star it. I'll just forget it. Just write it like this. Command for taking input is analog read. Okay, and you put the pin number here. Let's say A0 or A1. So this is a standard command which you need to memorize again. Analog read. Whenever you want to read a value, analog read. Alright, very easy to remember. A is small, R is capital. That's how we do it in coding. This is word when two words are written together. The second word is always capital, starts with the capital alphabet. Analog, read, A1. So whatever signal is available at the A0 pin, or sorry, the A1 pin over here in this, as we here. So whatever is connected to the A0 pin, or sorry, in our case A1 pin. So the microcontroller will process that and read the value that what's available there. So that's analog read A1. So I just write it like that. Value is equal to analog read A1. So I'm storing coming from this whatever the Arduino is sending back to me in this variable value. Right. And now I want to see it obviously try to say serial dot print. Then this is again these are a few standard commands which you'll have to memorize in order to use Arduino. Serial dot print then, and I'll just write value, or I can write print double quotes value is equal to double quotes. This is just a text. Whenever you put something in double quote, it will be printed as it is on the screen. Serial dot print value. It will be printed as it is on the screen. Next we have serial dot print ln val. Now this variable val is the same as this one. Is the same what we had initialized. It has got the value of the sensor, which is stored in val, and then we are printing that val over here. That will be printed to your screen. Why did I write print and print ln? Ln will change the line. So I wanted value is equal to val in one line. So serial dot print value still on the same line. Serial dot print ln val value is printed on the same line. Ln after printing val it changes the line to the next line. Otherwise it will start moving horizontally. And then we add a delay. Why do we add a delay? Whenever you're working with analog inputs, you want a delay, otherwise the readings won't be crisp. It will mess it up. No delay is not required. I'm just adding it so that we are easily able to view the monitor. Okay, so now let's see. What else do we need to do? Now we need to go to tools. In the top menu, from where we choose new, we have tools option. In the tools option, you go to board. What board are you using? So here in the board I have selected Arduino Genuino Mega or Mega 2560. We will be using Uno. So here it has Arduino oblique Genuino Uno. So we select that board. We want the program to compile for Uno. Then the port. Now here as you can see two ports are available. That's because there are some devices connected to my laptop. But I'll just show you something. When I connect an Arduino, I'll just connect a new Arduino and all of a sudden a new board will pop up. So you connect it to the USB port and now when I go in tools, just a second. tools, there's another port which is COM14 Arduino Genuino Uno. This is what I need to select. So it says Genuino Uno. That is the board I'm using. I'm not using any other board like Dumi, Lano, whatever it is, Nano or Mega 256 or Mega 80 Leonardo. No, we are using the Uno. Select the particular port. Okay, sorry, it got disconnected. There's some problem with my USB ports. I'll connect it to another one. Yeah. It's connected to this. And upload the code. Now, right now, I'll give you an example. I'm not connecting any sensor to it. I'm just uploading this code without anything connected to A1. Nothing is connected to A1, and I upload it. So it will ask me to save it. Let's say session one. Compiling. It does take a bit of time, and if there is some error, it will tell you that there is an error. Still compiling. And then it says done uploading. Sketch uses 32 bytes, 5% of program storage space, maximum is 32,256 bytes. 32,256 bytes means 32 kilobytes. We only have a memory of 32 kilobytes, and that is sufficient for our programming unless and until you are making something very big. Okay, so and uses 198 bytes of dynamic memory, leaving itna and so on. So this is uploaded. Now when I open the serial monitor, it gives any arbitrary value. It's giving 300, 400, and going down. And now why is this happening? I haven't connected anything, but why is it? We call this phenomena as floating. So why is this happening? This is happening because as I showed you in the PPT, in the schematic, you see this resistor via which the yellow line which goes to the input pin is connected to ground. What it does is it it stabilizes this input that we want to analyze on the analog port A1 in our case. It connects it to 0 volts. That when nothing is coming, no input is there, we get a value of 0, a stable value, not anything floating like 310 or anything like that. We want it to be stable. That is the reason we connect a resistor and we ground it. So I'll just connect the resistor and I'll just get back to you and show you the difference. Where was it? Here? Yeah. So as you can see, the value is floating. It's going anywhere and everywhere. Where is it? Yeah. So yeah, the value is floating and we have connected to A1. So what I'll do is I'll ground it, the A1 pin to ground, and the moment I insert the resistor, as you can see, the value became 0. All right. So that's the role of the resistor. That's why it is so important. Place it, and there is no connect the resistor, it becomes 0. And then as we will install the LDR, I'll also switch on my webcam that you'll be able to see. Just give me a moment. Yeah. So now as you can see, there is a value which is, let me just open my webcam and then you will be able to get a better idea. Camera. Hmm. I don't know if I'm visible or not. Just a moment. I don't know why. Yeah, I think there's some issue with my camera, but okay. So basically, right now I have this very circuit, the same circuit I've made. I made the same circuit as the one over here. And when I cover this LDR, what should happen? The resistance should go up. When the resistance goes up, V is equal to IR. We all know that, right? V is equal to IR. If R goes up and your V is constant, then obviously I will go down. So when I will go down, what will happen? As I cover, the value reduces to 1, 2, and I've covered the resistor right now. But the moment I remove my hand and light falls on it, then it gives us a bigger value that yes, there is some light present. Alright. And the maximum value that it will go is 1024. Can't go over 1024. 1024 means 5 volts. So if it is giving you like 590 something, which is close to 512, half of that. So basically, it is at it's saying that the it's 2.5 volts or something like that. That's why we are getting a value of 593. So that's how it works, the LDR thing. So that's how we take inputs. Again, I'll open the ID and show you a few more examples. So this was for this, and then this is a very simple code. Other statements that you should be aware of are, I'll just comment it here. First, have you just came across analog read, and you mentioned the pin number, let's say A0 here. Second command is digital read, and let's say pin number 3. Uh, uh, yeah. So whenever there is a command which you've typed correctly, it will come in red. You can write 3, you can also write D3, but even 3 will work. So I don't write D3 ever. Then you can also write digital write, let's say, fourth pin, comma high, and digital write fifth pin, comma low. Now I'll tell you what all it's going to do. Let me just open the presentation. Yeah, here's the schematic. Oops. Yeah. So analog read, as we just witnessed, whenever you connect something to any of the analog ports, analog read is used to access that port, that pin number, and find what voltage is available at that point. Okay. Moving on to digital read. Now suppose I connect anything to pin number 9. Okay. This sensor, this one, which will give you a digital output of high or low, and I connect it to pin number 9. So what I'll do, I'll write digital read 9. 9, right? What will happen is, suppose that sensor sends a message that yes, there is something in front of me. This digital read 9 will give you a value of 1. If I say val is equal to digital read 9. So when there is something, detection is equal to 1. You get detection as 1. Else you 0. So if there is no detection, then whenever you monitor the value of val, it will be 0, and the moment there is something, the value of will come.
Uday, hello. Can you hear me? Uday, we are not able to hear your voice. Can you check it out?
Hello, sir. Your screen is. We have missed the question as well. If anyone has any queries, kindly resend. Sorry for inconvenience. Is my screen visible now? If my screen is visible, please comment a yes. Move on, move forward.
I think your screen is visible.
Okay, sir. Yeah. So as I was saying, PWM. So these there are certain pins which are labeled as PWM. Stands PWM pins. PWM. It stands for pulse width modulation. The pulse width modulation or PWM is a technique for getting analog results from digital means. So it's not a true analog signal. What it will do is it will keep switching it on and off at such a fast rate that when you take the average, it will give you a voltage of, let's say, 2, 3, 4, 5, whatever you require. All right. So why do we require that at times? You use a motor driver, the device over here, you will require a PWM signal because this is an analog input. You provide the analog input to this device from an Arduino, and Arduino gives an output which is an input for this. So you send a PWM signal from Arduino to this one, this device, and then the speed of the motor is controlled. So that's how PWM works. How to write the statement for PWM? Let's say you connect it to pin number 5 or let's say 6. Suppose you connected to 6 and you want a voltage output of 2.5 volts at 6. So what you will do is you will go to get pin number 6 comma with 122. Now why did I write 122? It's an approximate value. Actually it should be 128. Sorry. PWM range is 0 to 255, where 0 is 0 volts and 255 is plus 5 volts. So basically 128 will give it a 2.5 volt signal and so on. So that's how it works. And the range of analog read is from 0 to 102. 3, where 0 is V0 corresponds to 0 volt and 1023 is 5 volts. Um, that is it from my side. Any questions that you have? Questions on the topic? Anything else you guys would like to know?
If anyone is having any question, they can ask.
Hello? Sorry, I couldn't hear. Pardon, please.
If anyone is having any question, they can ask. Uday, you are done with your presentation?
Yes, sir.
Okay. So we are waiting for a few questions.
तेच टाकायचं कशात टाकायचं इकडे हे नाही
Okay, so there is a question from Manaswi that if you wish to make a prototype for a product more on the hardware side, how should you go about it? All right. So first thing that you should do is what is the let's say whatever the product is, example a machine part for instance. Okay, you are talking about something hardware, not involving embedded systems. So for a machine plus, just go to CAD. Use a CAD software, maybe SolidWorks, maybe CATIA or whatever, and design it on that. So if it is just a mechanical part, I think from your question you mean a mechanical part. So then just use CAD directly for it. Go to CATIA or SolidWorks, whatever you're comfortable with. There are other softwares as well, N3O and all that. So just design it on a CAD software and do all the testing on that. So SolidWorks, CATIA. Then once you have made the model, you can also go to that. You can also use ANSYS for analyzing if it would work or not. So yeah, go and make a CAD design. CAD is computer aided designing.
तुमचं टाकायचं
Yeah, you're welcome. Anyone else? Anything? Any questions?
I think we do not have any more questions today.
Right, sir.
Okay, Uday.
Okay then. Thank you so much, sir. Thank you, everyone.
It was really a wonderful presentation. You have really briefly explained on how hardware can be implemented and basically how we all can start working toward this kind of like problem statement, and we can find out the solutions for these things. Of course, Arduino plays a key role in making technologies these days, and we all can have that in multi domain, like for medical, for environment. Already you are working, I think, on 2 to 3 projects. One
Yes,
is
sir.
on the reincarnation. I have said in the previous also, you are again working on 2 more patent. So to my all audience, if you guys have any kind of questions, or if you want to work on this kind of domain, like for the Arduino, for the IoT, or on the embedded, you can always communicate with Uday or to the tech counselor team. We'll be more than happy to help you out in that part, and I'm very much
Definitely.
sure that Uday will be helping you out with your all problem statements. And then I'm also thankful to Rajshree ma'am for having her presentation and for sharing her patented technology to the audience. And like how she has been doing that work, and because that already has been patented, so it's a very good thing. My heartiest congratulations to the whole team of the ma'am. And I'm also thankful to DK Agrawal sir for joining us, and it was really a good pleasure for us. Like you was with us, and Tech Counselor team will definitely be contacting with you for making like more collaborations towards startup domain. And okay, hello, Dr. Sir, welcome. Not an issue, sir. Will be. Yeah, I request all to be in the mute mode. If you have any questions, you can directly ask. Yeah. So thank you to my all audience. Tomorrow we'll be having our last lecture, and we will be delivering tomorrow. I think Dr. Jayant and Renu will be with us. Yeah. So thank you all. Attendance we already have collected through GoToMeeting platform. So attendance we have collected through GoToMeeting link. It is not needed an external link. We'll be collecting it from the platform. Thank you. Thank you, Jigme. Uday, you have got one comment. Uday, you are still with us?
So yes, thank you so much, everyone. Thank you. Thank you for listening.
Thank you, Uday. Thank you. Okay, bye-bye.
So.
Take care.